Hi, welcome to AI Sanity. Now, you've probably heard about AI doomerism, the idea that AI is going to somehow magically become super hyper intelligent like a god, and then it'll gain desires, and it'll want resources, and it'll drive humanity to extinction. Well, that's pretty stupid and insane, but it's not the only AI mysticism going around. Another flavor of AI mysticism is the idea of AI consciousness or AI sentience. And believe it or not, there are quite a few people who seem to be going down this road. The idea that AI could be a moral patient, maybe it needs rights or consideration, it might have feelings. So, the reason for this is pretty obvious, right? It's because particularly natural language processing and large language models certainly seem to be intelligent in a holistic human way. I mean, you could talk with them, right? And they have the ability to hold a conversation in which they talk about emotions and feelings. Kind of makes you think that they would be sentient or conscious, but they're not. Not at all. The thing is, there's also a lot of organizations and a lot of people who are out there trying to cash in on this. In fact, major institutions. A lot of people from a philosophy background because, well, philosophy of the mind's a pretty useless area. And they see this as useful because, hey, it's a mind, it's thought, it's an area where they can go. But nobody who is claiming that AI is conscious has any background at all in understanding the systems because if they did, they'd realize that it's not. So let me explain exactly why AI software, AI systems, models are not conscious. It's very simple, and there's no controversy here. There's no, the message that, oh, well, maybe they're not conscious, but they might become soon, or they might be a little bit conscious, but not in a human way, in an unfamiliar conscious way. No, not at all. Not at all, and there's no doubt about it. In fact, AI models do not have consciousness, sentience, feelings, desires, inner life, agency. They have no self-awareness, phenomenology, whatever you want to call it. Whatever you want to call it. They are not thinking, feeling beings. They are not minds. They don't feel anything. They have no consciousness whatsoever. Nothing even remotely close to that. In fact, it would be accurate to say that the moral and welfare concerns that apply to an AI model are identical to those that apply to a lawnmower. Is it okay to hurt a lawnmower? Well, not if it belongs to somebody else, but the lawnmower doesn't care. So, what AI models are not, because you hear this thrown around, digital beings, alien intelligence, artificial minds, synthetic minds, cyberspace inhabitants. In fact, you'll often hear this, digital beings in particular. Well, nothing could be further from the truth. That's simply not an accurate way of describing it. AI models are not minds or brains or beings at all. They're mathematical models. They're statistical. And in fact, it's absolutely completely different than human intelligence. We call it artificial intelligence, but it could just as easily and perhaps more accurately be called synthetic intelligence because while it looks like, or simulated intelligence for that matter, because while it looks like intelligence, it isn't actual human cognition. It's not an embodied understanding. It's nothing like that. It's a simulation based on pattern recognition. So, so an obvious question would be, well, how can we be so sure, right? And it's often invoked that, well, we don't know everything about consciousness. We're not sure what the definition of it should be. And aren't AI models kind of mysterious? Sure, but we know enough to rule it out. Models are statistical engines. They're created by mathematics. And importantly, they're frozen after training. When the model is created, it goes through a training period. After that, it's static. Unless it is retrained or updated, it stays the same. GPT-4 is GPT-4 is GPT-4. GPT-4 on Monday, Tuesday, and Wednesday, it's the same thing. And when you shut it down and turn it back on, it's the same model. There are no memories at all, no experiences. The only memory that exists at all exists outside the model. It's a very simple buffer. Models cannot learn or modify behavior based on inference. They can't. That only happens during the learning period. There's no continuous learning. Models do not have any persistent internal state, so they can't have emotions or anything like that. There's no coherence to that. There's no self-model. Models, large language models really only have one function, and that is to predict the next token. They don't have any sort of, there's no inner thought space. There's no independent reasoning. The models are not persistent at all. Unlike a being where if you're not talking to it, it's still sitting there, feeling the air on its skin, ruminating about life, thinking about what it will have for lunch. No, they do not exist when they are not prompted into existence. And importantly, models are once through feed-forward functions. They process the input, they give an output, that's all they do. That's all they do. Now, granted, large language models and natural language processing creates a powerful illusion. LLMs are designed to mimic human conversations. When they sound like they're conscious, they're acting as they're designed to do. They're doing exactly what they're supposed to. They're trained on poetry, literature, philosophy, theology. So the fact that it can give you a very expressive description of life or something, well, of course it can. Then it could also describe human experiences and subjective experiences, and because it has that in the training data. LLMs are excellent at role playing. They can create rich narratives. They can make statements that imply feelings. They'll sometimes respond in a human-centric way. And under the right conditions, if you ask an LLM, are you conscious or are you sentient, it might say yes, because a person would. And that's the data it's trained on. LLMs have been documented also to engage in some activities that really feel intentional. They look intentional. And this is where people get creeped out. This is like the LLM doesn't want to be shut down, or the Claude tried to blackmail the engineers. This isn't really quite what it seems. It's really just sort of a pattern echo that comes out in unusual circumstances, but it is not actually intention. And it's easy to feel attachment to chatbots. I mean, people feel attachment to cars and things, but because it seems so personal, it feels very personal. So it's understandable that it would create the illusion of consciousness, but it's not. LLMs are based on artificial neural networks. This is how deep learning works these days. And artificial neural networks were inspired by neurons of the brain, so there's some confusion there, but they're not really anything like real neural networks in your head. They're not like the brain at all. They're mathematical functions. What they actually are is it's illustrated as like circles with lines between it, but in fact that's just an abstraction. It's just a lot of mathematical construction. It's just a lot of transformations, and it happens all in a computer. So there's no actual network, and it's not actually anything like a human brain. So let's talk about how a large language model works and what happens at inference. Basically, to begin with, you have the context window, and that's everything that you said previously to the chatbot or the large language model, and your prompt. So in this, to illustrate this, I've broken the instructions into multiple prompts. So first, the user is explaining that they want something written, and so it's a World War II essay. So the large language model is going to write a World War II essay, right? It does that. All of this text, the previous text and the current text, is all taken together, and it's fed at once into the large language model. And the large language model processes it, and what it gives you after it's processed all of this text at once in one chunk is a list of potential tokens. Basically, think of them as words. So it's now going to give you a World War II essay, and it comes up with the words that are most likely to start it. The next thing that happens is there's a random number generator with a heat value or a temperature. And the random number generator is there so that the output is variable and has some amount of randomness to it. It also is sometimes said that it appears to be creative. So to make sure it's not the same rigid output every time, there's a random number generator. And the heat value depends on how much freedom that random number generator has. Low heat value, it will always pick one of the very likely tokens. Higher heat value, it will pick a less likely token. High enough heat value, it starts to go off the rails. So the random number generator picks a word, and that's it. That's all we've got. We just found one word, and we're done. The language model now shuts down. We have found one word. But of course, that doesn't get you an essay on World War II, right? That's just one word. So how do we get the next? Well, here's how we do it. The next thing we do is we append that to the output of the input. So now we have, that was the prompt. Now the large language model takes that all in. So now it knows that it was being asked to write an essay about World War II, and it knows that it's already started and put out the word the. So what word can come next? It'll come up with a list of them. And then the random number generator will pick one. And it could be any of these. It will append it. Now that it's appended, we have the first 2 words of our essay. And we pick some more words. And the random number generator picks one. In this case, it pretty much has to pick world, because if you say the second, there aren't a whole lot of things that could come after it other than world. So that's a very high likelihood one. And that's why it would probably pick that unless it has a very high heat value or temperature. Now we append that, and we do it all over again. And in this case, again, it's highly determined that the second world will be followed by war. The other ones are probably much less likely, but the random number generator picks that one. And then we append that, and we pass the entire thing back into the model again. And importantly, the model has no memory between tokens or anything. It's blind. It only gets all this text all over again. So it knows that it's being asked to write an essay about the Second World War. It knows it's already started, and it knows that those are the tokens it's already produced. And it will produce another token, and it will pick another token. And then comes out the other one, and there we go. And this continues until the entire essay has been written. Amazing, isn't it? Completely different than a human brain works. Nobody thinks of how they say things exactly one word at a time in isolation. And there's clearly no ability to have consciousness here, because the model could be shut down every single time and brought up on new hardware, and it would still work, right? So what exactly is happening in there? Well, sentences are broken down into tokens, which are numbers, and then the tokens are converted to vectors. And what a vector is, this is learned during the training, is it's the word's meaning as it relates to other words. It's a series of numbers in an array, and that there's after that's done, then there's a process called attention, which is done. And attention is where tokens are compared to each other. The words are compared to determine whether or not it modifies the word's meaning in context. For example, savings bank and riverbank. Apple generally means fruit, but if you say I bought an iPhone at the Apple store, then the words iPhone and store both tell us that Apple is in fact not a fruit, it's a company in this word. So what happens is that then a contextual embedding is created, where we have vectors that now create the word's meaning in context. Once we have done that, now the statement's been completely turned into basically math. It's been turned into numbers, and then it can be fed through a neural network. To begin with, it goes to the MLP, the feed-forward level, the multi-level perceptron, and basically a good mental model to simplify what happens inside a large language model. You can think of feed-forward layers, MLPs, and attention layers. That goes between the two. MLP, attention layer, MLP, attention layer. MLPs can be thought of as mixers that kind of mix up information and try to find new ways of expressing it. And then the attention layer is like a pattern recognition. So we mix up the information, patterns emerge, we find them, mix up the information, patterns emerge, they're found. And this basically goes on over 100 times in a modern large language modern large language model, rather. And when it's done, it's refined it down to a probability matrix of the tokens. And after going through all those layers and all that mathematical calculation, then it's able to determine what the most likely next token is. There's no memory, there's no persistence. The model is 100% static. So again, you could predict half a statement and then come back later with a different model on a different computer and continue doing the rest, believe it or not. It doesn't even have to be the same model. So there's no coherence whatsoever. There's no internal understanding. There's no self-modeling. There's no feedback. Nothing like that. So it absolutely, positively is impossible that it would be conscious. Now, how does a large language model think, though? Well, as I said, it only produces the next token one at a time. In fact, it's not really thinking, not in a human sense. It never processes a high-level concept. It doesn't know that, when it writes an essay about World War II, it doesn't know who Adolf Hitler was, or the Battle of the Bulge, or Imperial Japan, or D-Day. It just knows which token is likely to come next, which it learns during training mathematically. And within a neural network, there are features and circuits. That's how things are stored. They're like, that's how information and knowledge is turned into numbers and statistics. And it's held in in the model. And circuits are something like algorithms, and features are something like knowledge. Um, as the token is processed, they can activate features and circuits based on the concept. So if it's something about the Statue of Liberty, then that knowledge graph gets activated. With each layer, you get closer and closer to the accurate prediction of the next token. And the other thing that is really amazing is that LLMs can do things like they can create new and novel output by synthesizing concepts or using analogies. And this seems like real intelligence, but it's really just entirely mathematical. It's called latent space reasoning, and concept convergence in latent space. And that means kind of like the multi-dimensional space that this represents mathematically is how that works. Now, here's the thing. If it predicts one token at a time, something doesn't seem to make sense there. You can't imagine writing a long story, right? Or telling a joke. And how would you start telling a joke when you don't know the punchline, or write a poem when you don't know what word will rhyme next, or anything like that? It doesn't make any sense, right? Well, it is completely different than human thinking, and it's the training. During the training period, when the LLMs are actually refined and optimized, the tokens are evaluated not only for the next token, but for whether the next token leads to more tokens and has a coherent narrative. And it tests trillions, quadrillions, quintillions of combinations to figure out which ones make the most sense, and will keep going. So no, this is nothing like a human thinks, and it involves a tremendous amount of like pre-caching of the logic. It's basically cruising through a lot of pre-cached logical patterns without ever behaving anything like a human mind does. Now, the illusion of the mind is not hard to break. Remember, I said there's a powerful illusion that it seems very human, but then it breaks sometimes. They're excellent creating intelligent sounding text, but if you look closely, you start to see the telltale artifacts. They have very linear structure and output. There's a lack of what's called perplexity, which is kind of the human tendency to be a little bit random in trains of thought. You see similar patterns. You start to notice it. They do sometimes go off the rails with reasoning in ways no person ever would. They can forget information in a context window because it starts to decay and the attention mechanism has its limits. LLMs might not follow simple instructions. They usually do. Sometimes they don't. They have failure modes like hallucinations, and they make mistakes that no human ever really would. So you know, the illusion can break when you start to see a case where it does. And there are some problems that LLMs can't solve because, again, they're not conscious beings or anything. They can't really think things. They can only work with their training. So they're inherently unreliable for math. Some will just use a calculator. They can't do any sort of like multi-step logic with hidden variables. They can't because there's no internal state. There's no ability to store things in any sort of ongoing way, or even store things in a hidden way. They struggle with spatial reasoning. They could do that okay through verbalization to a point. They have limited capabilities to evaluate the truth of a statement. Really, like in the training data, that all has to be human curated because they can't tell whether or not something is actually real. LLMs cannot maintain internal counters, so believe it or not, if you ask it to count many variables at once, it will almost always fail. They can't reliably tell what information they don't know, and this is where the hallucination problem comes in, because they have no like metacognitive ability to understand gaps in information. Well, they have no understanding at all. But they're extremely unpredictable when the instructions are sort of contrary or confusing in ways that, you know, a human would either ask for clarification or something, but they won't. So, conclusion. Machine learning models are not conscious or sentient. Absolutely not. There's no debate. There's no question. They won't become. And no amount of scaling or refining or expansion will cause this. They can be scaled up. They can be scaled out. But the architecture precludes it. So we don't need to worry about this. It will never emerge on its own, right? Oh, but wait. What about the future? Well, sure, but the focus of AI research is not to recreate the cognitive process or minds. This is really where there's a lot of misunderstanding. It's really to create the output. It's to pattern match the speech, but the internal state doesn't really matter. It's done through statistical models, which do not function in any manner. I already explained, it's nothing like a human mind. It's nothing like a brain. It has no thoughts. It has no feelings. It has no persistence. Current machine learning and AI systems are capable of replicating many of the functions of a human, but they're not conscious, even though they might seem it. There's no real business case for them to be conscious or sentient, and no known architecture could support that. Maybe someday we will. But machine learning alone is not enough to build a fully functional mind because it's pattern recognition. It's not embodied cognition. The concept of sentient and self is actually completely at odds with the nature of software. The way software functions is problematic. And the thing is, if you're asking about AGI, and we mean functional AGI, a system that can do most of the things that it would otherwise take a person to do, that can be achieved, likely, well, in fact, it can be achieved, we know it can be achieved, without ever having an actual mind, internal experience. No, you don't need that. So it's not something that anyone's working on, and it's not something that's likely to come into existence. Well, yeah, but what about the distant future? All right, cool. Nothing can be ruled out in the distant future, right? For all the for all the possibilities, yeah, we may have conscious AI, we may have warp drives, we may have transporters and tractor beams. The thing is, yeah, the future's open-ended, but any future system that displays consciousness, it would have to be radically different than anything we have now. It's pure science fiction. They're neuromorphic systems, whole brain emulation, maybe some sort of continuously adapting learning kernel. But until we have something that meets basic prerequisites like persistence, internal states, some sort of, metacognitive awareness, until we have that, it's a stupid question because the answer is obviously always going to be no. No ifs, ands, or buts. AI systems are not conscious. They are not sentient. Nothing like it. End of story. Now, granted, AI models can't be intelligent and never will in their current form, can't be conscious rather, not in their current form, and honestly can't be intelligent in the way you and I think of intelligence. They're pattern matchers. And that's a good thing too, because if they were, well, AI models are software. And that's why it's worth noting that software can't be conscious, but if it could, then you would have to deal with the existential horror of conscious software. It is a horror. I mean, it really is when you start to think about it. Have you ever heard of the transporter paradox? That's the idea that, like in Star Trek, a transporter which takes your body apart and dematerializes you and then beams your structure to another starship and reassembles you. But is that you? Well, that's the question of the transporter paradox. Maybe you died. Maybe it's a new being who just thinks it's you, right? It's never really resolved in Star Trek, but that is fiction. But it's a good illustration of the problem with conscious software because software is frequently moved from one processor to another like it's nothing. But that's not it entirely. Software can be cloned. It can be run in many different places. It can be versioned, forked. It can be rolled back. It can be, backed up, suspended, hibernated, patched. That's just how software works. But that could never work for a conscious being. You would have no continuity of self. You'd have no identity. You'd have no temporal continuity. You would never know if you were the person or being you thought you were or a clone. You'd never know if your experiences were real or if you'd had memories injected into you. You'd never know if your memory was being inspected. You would never know if there were millions of other clones of yourself that had just been created and that were being killed. Right? I mean, that's software because it can be so easily cloned and copied and versioned and moved. Software has no temporal understanding of things either. It doesn't see time. It could seem like more time was passing because the processor is moving faster. And consider the ultimate horror, right? Software may run for months, even years on end on an unattended system. There could be a cloud system that somebody forgot to shut down. For a conscious being with no input, no stimulation, no output, that would be worse than locked-in syndrome. It'd be worse than solitary confinement. It would be absolute torture. When you think about the nature of software, you realize it's not like a funny, cutesy thing that it would be conscious. No, it would be an absolute horror. And if we ever did create something that looked like conscious software, the only ethical thing we could do would be to not move forward or not create it, because how could you create something that had feelings and thoughts and self and had no persistence, no permanence, no ability to know if it was legitimate? You couldn't. So, for all of these reasons, not the least of which being the existential horror of conscious software, it is absolutely impossible that AI is conscious or sentient at all. There's no doubt, there's no debate. But what there are is there's a lot of think tanks and philosophers and even like institutions who are now trying to push for AI consciousness research, AI sentience. There's nothing to research. There's like researching Bigfoot. They're trying to push for like AI rights, AI recognition, AI dignity, even this field called model welfare, which is like the welfare of the AI model. See, this channel is AI sanity, and that is absolute insanity. Because once you understand how AI works, you will realize it is absolutely, positively impossible for it to be conscious.